Hello everyone, and welcome to the 2020 edition of the European Researchers' Night, which is sponsored by the European Community in order to promote scientific research. Tonight, a few hundred events are taking place at universities and research institutes throughout Catalonia and the rest of Europe. My name is Roberto Raddi, and I am an astrophysicist at the Universitat Politecnica de Catalunya. In this video, I'm going to talk about the fastest stars in our galaxy and how we find them and why they are so important from the point of view of astrophysics research. So, the night sky is one of the most amazing displays that we can see in nature. Although we can see already a few thousand stars with naked eye, we know that they are just a tiny fraction of the largest number of stars that are actually populating our galaxy, the Milky Way. And by taking images all sky, it's possible to have a global view of the Milky Way, our galaxy. For instance, from this image that has been taken by the Gaia satellite, you can recognize that the Milky Way is this kind of flattened structure in sky, and we already can see that in the center of it there is a brighter spot, which is the center of our galaxy. From the figure you can also recognize two nearby galaxies, which are the Magellanic Clouds. They are visible from the southern hemisphere of the Earth, and they are galaxies that are interacting with our own galaxy. All this information that we know about the Milky Way has been produced by years of study by looking at the stellar population surrounding the Sun. And so nowadays we can produce a map like this one that describes the Milky Way as seen from above. Essentially, it's a disk of stars, and the Milky Way itself is a spiral galaxy, which means that the majority of newly formed stars appear to be distributed along these arms of a spiral. And so the Sun appears to be located at a position that is slightly farther away from the galactic center, which is the brightest area in the center of the figure. And all the stars, along with the Sun, rotate around the galactic center. Especially the Sun and the stars nearby it appear to rotate around the galaxy with a velocity of about 250 kilometers per second, which is a very large velocity, but it's normal compared to the typical velocity of stars. And so when we are talking about the fastest stars in the galaxy, we are talking about stars that move up to a few hundred kilometers per second, even 1,000 kilometers per second. How do we know all this information about the galaxy and the stars that live within it? We can study their positions, distances and velocities from ground-based observatories or from telescopes in space. One of these telescopes is the Gaia telescope that has been working now for a few years and has been able to discover and measure positions for up to 1 billion stars in our galaxy. How do we do that? We astronomers measure angles relative of stars, position of stars, and angles relative to each other. And this is a very ancient technique. It's been discovered by ancient astronomers, and it's something that you can verify yourself. For instance, if you are looking at the position of your finger and you look at the finger and its position with respect to a farther away background, if you close one eye or the other, you can see the position of finger changing with respect to the background. And so the satellite does the same thing by changing position around the Sun orbiting around it. And so by changing position, the satellite measures a relative change of nearby stars with respect to the most distant ones, and this angle, which is called parallax angle, corresponds to a measurement of the distance of the stars. So by doing so, we can measure distances of stars, and at the same time we can also measure the movement of stars, which is called proper motion. And so for stars that are nearby, like the Barnard star that you can see in this animation, you can measure very fast movements on sky. And so it's very important that we measure very tiny changes for the farther away stars, because the tiniest changes could actually correspond to very large velocities. And finally, the last thing that we need to know about stars is the velocity with which they are moving towards us or away from us. And this is something that we can learn by looking at the light emitted by stars. We know that stars that are moving far away from us will appear redder than they are, and stars that are approaching us will appear bluer than they are. And so by measuring this change in color of stars, we can measure the relative velocity with respect to the sun. And so by knowing the apparent motion on sky and this change in color, we can know all the distribution of velocities, and then we can also know the positions of stars. And so in this way we have been able to identify stars that move much faster than, for instance, the sun, stars that reach velocities of 1,000 kilometers per second. And these stars have been called runaway stars because they are escaping from their original locations with very large velocities. And one important thing to understand is how the stars have been able to escape. And one of the phenomena that are capable to eject stars with very large velocities are stellar explosions, which are also known as supernova explosions. So for instance, if you have a binary system, which is two stars orbiting around each other, one of the two stars, for some physical reasons, can explode. And so when it gets destroyed, you will have the other star being ejected from this original position with a very large velocity, as you can see in this video. And so after that you have the explosion, you will form a cloud of gas that is rich of all these elements that are produced during the explosion. This is something that has been observed by astronomers, very famous ones like Kepler and Tycho Brahe, which looked at the explosions of stars and then trying to understand how these things can happen. And so after you have a supernova explosion, you form this cloud of gas which is rich with heavy elements processed during the stellar explosion, and then you will have the companion star that is ejected with very large velocity. And so one of the important things that we can learn by studying the stars that are ejected is what explosion produced them. And the important things that we can learn from supernova explosions is how we have heavy elements, all the elements we actually have on Earth, how they are produced. And so you might be familiar with this figure, which represents the periodic table of elements. And you can see that all the elements that have blue and orange colors are those that are produced during supernova explosions. And so the majority of them are actually produced during this very energetic phenomena. And finally, before concluding, I would like to show you an animation describing the motion of these very fast stars in our galaxy. So you can see in these two panels an example, a representation of the Milky Way seen from the side on top and from above at the bottom. And you can see four stars, which one represents the sun, the orange star symbol, and the other one are these runaway stars. And so while the time goes, you can see on the left, top left corner of the figure, the million years elapsed from the explosion of the supernova. And so when I start the video, you can see two of the stars moving very far away from the galaxy and being lost into the intergalactic space. while this other one, this red object, is going around the Milky Way. So by studying the motion of these objects, we can understand where they come from, and we can also understand how they were ejected. So we can learn a bit more about the universe surrounding us. So in conclusion, I would like to thank you for listening to my video, and I would invite you to keep watching us in the webpage of the European Researchers Night in Catalonia. Goodbye.